Great. So we are, like I said, we're wrapping up chapter 7. This is sort of like the concluding unit where it's, okay, we simplified radicals. We graphed radicals. We rewrote radicals as exponents. We simplified radicals as exponents. So the last thing we're doing is solving radicals. You have two radicals equal to each other. These are really nice because if you have a radical equal to a radical, you square both sides and the radical goes away. So then it simply becomes a linear function equal to a linear function, which is basic algebra. Once we get your answer, you should just check to make sure that answer is in the domain. So like here, if you have this positive square root equal positive square root, as long as 9 is in your domain, then it's going to work because you're not worrying about a positive equaling a negative. So 2 times 9 is 18. 18 minus 13 is root 5. 9 minus 4 is 5. So square root of 5, in fact, equals the square root of 5. These are the trickiest because these involve taking the square twice. So if you have 2 square roots, I always suggest getting one on each side. Before squaring. That makes it that you're not multiplying square roots times square roots. So we're going to eliminate the square root on the left by squaring both sides. And then you're left with the FOIL type problem that we had from lesson 7.5 and 7.6. So when you square root and square, they cancel, so you get your x minus 4. And that square root of x plus 2 gets FOILed. So your first is x, your outer is 2 square roots of x, your inner is 2 square roots of x, and your last becomes 4. Moving x's and 4 to the left, combining my 2 square roots of x, we get negative 8 equals 4 square roots of x. We now want to isolate our square root. And I can almost stop here if I know and think about what I know. Any number you plug in for the square root, is it ever going to come out to be a negative number? No, because a square root itself is always positive. Its domain is positive. So if I get a square root equal to to a negative number, I can stop right there and say, oh, x has no solutions that are real. These are my special case. Because yes, if you did continue to work this problem, you get a value, but that value, when I go to check it, will never be true. And when we check, it's important that we always check back into the original, because you want to make sure you didn't make a mistake in solving somewhere along the way. Because if you get that solution that does not work, an extraneous solution, you should get opposites. Like your numbers should always be the same two numbers, one positive, one negative. If they aren't opposites, that's an indicator you need to check your math. Now remember, we only have to check our solutions if the root is even. Here we have a cube root. A cube root's domain is all reals. Therefore, we don't have to worry about it being positive or negative. So I need to isolate any type of radical. So I want to isolate what's boxed in. So I'm going to subtract that 3 from both sides. And remember that the cube root and the 1/3 power are equivalent statements. So we're going to get rid of that by cubing both sides. And again, you can take your answer and plug it in real quick to check yourself, but you don't have to worry about it being an extraneous